Another way to solve systems of linear equations is with a method called elimination. And the main time that you want to use elimination is when the two equations are written in what we consider standard form. And if you remember, standard form is ax plus by equals c. And that's basically just you have both constants, or I'm sorry, the constant is isolated and both variables are on one side. So we can see we have both variables over here on one side. You also want to use elimination when it's challenging to actually isolate one of those variables. So we talked about in substitution, if you have a variable that has a leading coefficient of 1, then it's easy enough to isolate that variable and then you can use substitution. So in this case, we're probably going to stick with elimination if we have a situation where one of those variables is not very easily isolated. Now, before we actually look at the examples in your foldable, I want to look at two other examples just to kind of talk about the basics of what elimination actually is. So if you want, you can add this into your foldable, maybe where you have some extra room or on the back. But let's look at this example first. 2x plus y equals 16 and 3x minus y equals 4. The word eliminate, we know what that means. It means to get rid of something. So elimination, the whole point of it is to add or subtract two equations together to get rid of or eliminate one of those variables. So in this case, you can see here that we have a positive y in that first equation and a negative y in that second equation. If I were to just take these two equations and add them together, I would get 2x plus 3x. We would combine those to have 5x's. And then a positive 1y minus 1y, those are going to cancel out. So these two actually eliminate, hence the name, equals 16 plus 4, we get 20 over here. So 5x equals 20, we have eliminated one of those variables, and now we just have a single variable in our equation. This is something we're really familiar with. We know that you could just divide both sides by 5, and in this case you get that x equals 4. Right? And then we would just want to find y by plugging 4 back into one of the equations. So let's say if I plug it into that first one, I would do 2 times 4 plus y equals 16. 2 times 4 is 8, so 8 plus y equals 16, and therefore we know that y equals 8. So our solution to this problem is 4, 8. Let's look at another one. Okay, so another example, 2x plus 4y equals 4 and 3x plus 4y equals 22. I can see already that if I try to add these two equations together, nothing's going to cancel. 2x and 3x would become 5x, 4y and 4y would become 8y. So this is a little bit different than the last example. But there is something that we can do. Instead of adding the two equations, we can subtract the entire second equation from the first equation. So 2x minus 3x, we would actually get a negative 1x, and 4y minus 4y is going to cancel. So then those are eliminated. We've eliminated y. 4 minus 22 is going to be negative 18. And then we would just divide both sides by negative 1, so therefore x equals 18. We would then plug it back in to figure out what y is. So I'm going to use that first equation. 2 times 18 plus 4y equals 4. 2 times 18, we know that's 36. So 36 plus 4y is 4. Taking 4 away, we get that 4y equals negative 32. So then y equals negative 8. So our solution here would be 18, negative 8. So I just wanted to show you that really the basis of this is adding the equations together or subtracting the equations from one another. So now let's actually go back and look at your foldable examples. So we can see that this first example in your foldable, if I add these equations or subtract them, nothing's going to eliminate, right? Because in this case, our y's, the coefficients, are negative 12 and 4, and the x's are 5 and negative 4. Those aren't the same numbers, right? So they're not going to eliminate if I add them or subtract them. They're not opposites of each other. So we're not going to be able to do anything until we take one of these equations and multiply everything in that equation by the same number in order to get a variable to eliminate that we want. So let's say in this equation, I can see that 4 here, this coefficient of y, this 4 is a factor of negative 12. I know that if I multiply 4 times 3, I can get a positive 12. So what if I just took this entire equation and multiplied it by 3? So that equation would become negative 12x plus 12y equals negative 12. Lots of 12s in there. So that's our second equation kind of revamped. We've taken the entire thing and multiplied it by the same number. And now I'm going to write down that top equation. It doesn't matter if it's first or second, but I'm going to write that one down. But we can see now that I have a positive 12 and a negative 12y. So if I were to add these together, now the y's would eliminate, and that's the whole point. So I can go ahead and add them. Negative 12x plus 5x is negative 7x. 12y plus a negative 12y, these eliminate, equals negative 12 plus negative 2 is negative 14. So we can see pretty quickly if I divide both sides by negative 7 that x equals 2. So we just want to plug that back in to figure out what y is. So I could do 5 times 2 minus 12y equals negative 2. 5 times 2 is 10, so 10 minus 12y equals negative 2. Subtracting that 10, we get negative 12y equals negative 12, and therefore y is 1. So your solution is 2, 1. So again, we were able to do this. We were able to eliminate a variable simply because we chose to multiply one of the equations by something the entire way across. I also could have multiplied by a negative 3, and I would have gotten a positive 12y, and then I would have just subtracted the equations to eliminate that y. And we have one more example there. The negative 7x minus 2y equals negative 7, and 6x minus 3y equals negative 27. It is up to you what you choose to eliminate. I'm probably going to try to eliminate the y's simply because when I'm looking at them, they have smaller numbers. So it's probably going to be easier. So I think about the fact that I have a negative 2 and a negative 3. Both of those are factors of 6. So I could, if I wanted to change that y in the first equation, if I wanted it to instead have a coefficient of maybe negative 6, I could multiply that first equation by 3. So that's going to change this to be a negative 21x minus 6y equals 3 times negative 7 over here is also the negative 21. So if I want to change the second equation, my goal is to eliminate the y's. So how can I get negative 3y to turn into either positive 6y or negative 6y? Well, I could multiply that by 2, and that's going to change it into a negative 6y. So I'm going to have, whoops, let me go ahead and erase that little mark. I'm going to have in the bottom equation 12x minus 6y equals negative 54. And I'll go ahead and bring down that top equation as well. The negative 21x minus 6y equals negative 21. Now because our coefficients of y are the same, in order to eliminate the y's, I'm going to have to subtract the entire second equation. So I'm going to do 12x minus negative 21x, and that gets us 12x plus 21x, which is 33x. Negative 6y minus negative 6y is really negative 6y plus 6y. So these are going to cancel. That's what we wanted to eliminate. Negative 54 minus negative 21 is negative 54 plus 21, so that's going to be negative 33. And now we can divide both sides by 33 to get that x is negative 1. Now we just need to find y, so we're going to plug that into one of the equations. So I could do negative 7 times negative 1 minus 2y equals negative 7. So negative 7 times negative 1, that's going to be a positive 7 minus 2y equals negative 7. Subtract the 7 from both sides, so negative 2y equals negative 14, and there we have y equals 7. So our final solution would be negative 1, 7.